What do you think this line of code will give you? These are the kinds of questions I ask in the quizzes, right? A range. You will start at 1.5. You will stop short of 2.4 in increments of 0.3. So the first item is 1.5 because you start at 1.5. The next will be 1.5 plus 0.3, which is 1.8. The next will be 1.8 plus 0.3, which will be 2.1. The next would have been 0.3 plus 2.1, which is 2.4, but it doesn't get to 2.4. So 2.1 is the last member. That's what you get from the function. You will find these very useful. You would like to be able to create items that increase in fixed intervals a lot. And for those, you use array, like we already talked about, start, stop, increment, so you can control what the increments will be, where you'll start and where you stop. You also have numpy.ones. So if you want to create an array that is filled up with ones, if you want to create an array that is filled up with zeros, I stands for identity. So you all recall what an identity matrix is, right? It is a matrix that is filled up with zeros except on the main diagonal, which is the diagonal that goes from the top left to the bottom right. In that main diagonal, you have ones. So ones on the diagonal and zeros everywhere else. You can create an empty list, and you will see that will basically just put in junk in the matrix, but it will have the right dimensions you want. And then you can fill it up with values you want using either the array.fill function or just specify this column, which means every item in the list, and you provide a constant value to put in all of the items in the array. So numpy.ones, what do you think this 2, 3 means? Can't see my mouse moving anymore. What do you think this does? The dimensions. So the array will be filled with ones, but the dimension is 2 by 3. Always the rows come before the columns. So it's an array of 2 rows and 3 columns. That's what this is, for a matrix of 2 rows and 3 columns. And it's filled with ones. So that's what you see here. Ones, right? 3 ones on the first row, 3 ones on the second row. And by default, it's of what data type? Floating point. You can change that, right? You can customize it, providing a second argument to the function. So you could have said mp.ones23, gtype integer, and then this will be all ones without the decimal place. So this is 3 by 3 array, so 3 rows, 3 columns, filled with what? Zeros. That's what you get here. I, which I said is identity matrix. There is also an alternative for getting the same result. I can actually run it, and then if I run the second one, of course this line will override what was stored in this, and you get exactly the same result. Identity matrix. That's exactly what an identity matrix is, right? Ones on the main diagonal, 0 everywhere else. 3 is the dimension, and because identity matrices are square matrices, meaning the number of rows is the number of columns, that's why you don't need to provide the dimension as a tuple. You all recall that these are tuples, right? It looks like list, but it's surrounded by regular parentheses instead of square brackets. So this already knows both dimensions will be 3. This knows both dimensions will be 4. So 4 by 4 identity matrix. That's exactly what this is, right? 4 items on the rows, 4 rows, 4 columns. and then once on the main diagonal. Like I said, this will give you an empty array that has 2 items in it. So this is a one-dimensional array, and the 2 items will be junk. Right now, let me run it so you're not confused. So I've just run it, and I'm asking for 2 items, and these are the 2 items. And what is in the value? In the first and second indices of that one-dimensional array, junk. This is a very small number, right? E raised to the power minus 30. So very small number. How about this? 2 raised to the power, E 261. So very big number. This is all junk. And then you will fill it up with whatever you want. So here we're filling it up with 5. And then when you print it on this line, you get 5. You can fill it up with 4 using this order approach column, which stands for all elements in A. Set it to 4, and then you get this. There is also lin spacing for linear spacing between the start and the end, and I want 5 numbers. So I want 5 numbers. Start at 0, end at 1. This is inclusive. So the first item will be 0. The last item will be 1. I want a total of 5 items. So I already have the first and last. I need 3 more numbers that are evenly spaced between 0 and 1. So you already know if you're going to have 5 numbers, then the interval between those will be 4. So this basically means do 1 minus 0 divide by 5 minus 1, which is 4. So 1 minus 0 is 1, divided by 4 is 0.25. So the spacing will be 0.25. So first member is 0, second member is 0.25. Third is 5, which is 0.25 plus 0.25, 0.5. And the third will be 0.5 plus 0.25, which is 0.75. And the last will be 1. And we can run it. And then you see that's exactly what you get. So it starts at 0, ends at 1. You want 5 members, 1, 2, 3, 4, 5. And you want them to be evenly spaced, where they are evenly spaced with an interval or stride of 0.25. You can also have numbers that are evenly spaced, but on the log scale. So logarithmic spacing, that's what we call it. And you all will get to work with these at some point, maybe when you do well testing in your 3rd or 4th year. So similar to NumPy's lin spacing for linear spacing, but here lin is logarithmic spacing. And you start at 0, in this case, you stop at 1. You decide what you want, where you want to start and stop, and how many members you want. So this is your logarithmic spacing. Next, we're going to talk about plotting in Matplotlib. So we use Matplotlib to plot. So we need to import matplotlib.pyplot. So import matplotlib.pyplot. Now you can see this is a long full path to what we want for the function we want for plotting. So you don't want to type this multiple times, right? So it's important to use the AskPLT. So of course, this can be whatever you choose. It just means whenever you're making the function calls, you're using the alias you use. But these are standard conventions most people use in Python. So PLT now stands as an alias for matplotlib.pyplot. What's the function of this stuff? Well, this is useful only in interactive Python notebooks like Jupyter Notebook. If you were to write a standard Python code that ends with .py for .python instead of .ipynb, which is what you are working on so far, which stands for interactive Python, you don't need this line or this command if you are working in .py. So just important to note, this line basically allows your plots to show up in this interactive environment. Whereas if you don't provide it, if you comment out this, which you have to do in .py codes, you still get your plots. So this is just a command to the interactive Python engine. So plt.plot will generate a plot. First argument is the x, the data that goes on the x-axis. Second is the data that goes on the y-axis. And this is the type of plot you want. G for green. You see the plot is green. Here, the plot is red. R. Here is green. G. You could change this to B for blue. Right? No, because I've not run the PLT. I want you to see it. So you guys will be running into errors a lot. The more you read these errors and then pay attention to the solution, the quicker it will be for you to fix errors in the future. So it says PLT is not defined and you're trying to use PLT. So I know that means I haven't run this part of the code before, because this is where PLT should have been defined when you imported it. So now it's still running. Now it's defined, and then I can run, what was I talking about here? I changed this to B for blue. What about black? Isn't it also B? I think it's actually K. I know that's it in MATLAB. Yeah, so same deal. K for the last letter in black. That's how you get your black plots. How about this single hyphen? It's for solid line. If you make it double hyphen, then it will be dotted lines. And all of this you can read up online. Nobody memorizes all of these by heart, but the ones you use a lot, you'll know them by heart. How about this S? It's for this square. But if I don't want it to be a square, I want it to be a circle, you can use O. And then the plots as circles, right? So you can actually control all of the parameters of your plot just like you would in Excel. So again, first axis is x-axis, the data that goes on the x-axis, the data that goes on the y-axis, and then green line, solid line, square. And show will actually get it to display. So important to have this function to actually display your plot. This is similar, right? But now we only provide one argument. Before we provided two data arguments, right? Apart from the instructions on how the line, the curve should plot. It's x and y axis. How come there is no x and y axis here? What do we have? What you have is the y axis. Whenever you have only one data item, it is the y axis. The x axis is implied and it starts from 0 and ends at the length of the data. In this case, the log interval. The length of the long interval minus 1. Because indexing starts at 0. So we started at 0, then we'll stop one short of the length of log interval. And log interval was that logarithmic spacing we created before. So it puts that on the y-axis, and then it plots it against 0, 1, 2, 3. Here it's how many members? 5, right? This is precisely the number you're plotting. 1 to 10, and there are 5. So it's going to start at 0, stop at 4. So it starts at 0, stops at 4. And that's what you get on this plot. Here you provide both the x and the y, and we already showed what this means. And we'll stop here in this video.